Hello, hello. I am audible.
Yes, sir, you are audible.
Okay, okay. We'll start within 5 minutes. Yeah, my slide is visible. Pradeep.
Yes, sir, visible.
Okay, okay. You are asking about. You have asked two questions or one?
Sir, last question, sir. The unit should be, I think, the kilogram per second, not liter per second. Is it not? The mass flow rate should be in kilogram per second, I think. Last
Okay,
question, sir.
okay, okay. Which
Uh,
one? The inner diameter of the hose. This one question.
yes, sir.
Oh,
They are asking, sir, it is asking question by answer by liter per second, mass flow rate. But mass flow rate, as I understand, sir, should be in kilogram per second.
yeah. But if you mass flow rate of what water?
Yes, sir.
Yeah, 1 liter water is equal to the 1 kg. Almost, almost.
Yeah.
Not yeah, almost those. That's why I think it's written here.
Okay. Yeah.
So I today.
Then two questions, sir. Then first two questions.
Okay, okay. Your which one? I think fourth wicket going on. Na?
No, sir. Third week is over actually.
Yeah,
Fourth,
fourth week will start.
yeah, it will start next week.
Okay, fourth week was about the dynamic.
Yes, sir. Yes. Mass conservation of mass and conservation of
Yeah,
momentum.
yeah. Okay.
The last, sir, we stopped at like last we stopped at this the equation derived for
Yes, yes.
mass flow
Okay.
rate. Yeah, mass flow.
Okay. Today the lecture.
That force
The
is equal to rho AV.
okay, okay. Basically, today the assignment questions about the Reynolds transport theorem and the conservation of mass and conservation of momentum.
Yes, sir. That is.
Still, student are not joined. Why not? Very few
Maybe
student.
assignments, maybe, sir. They may be preparing for assignments.
Oh, a date or last date of assignment of your this
Uh,
question?
16, sir. 16.
Third
16.
assignment. Third
Yeah.
assignment.
Third assignment, yes.
Today is 14.
14 years. 1 day.
14/8. Yeah.
Maybe
Okay. Oh,
tomorrow is a holiday, so
students
maybe.
should be joined. I think why not join? I don't know. Or Pradeep, you can suggest whether I change the mode of teaching. How can I teach the student? Then will join the more because this is my first time I am teaching.
This is
So
your, sir. This fine, sir. You're teaching well. So, you will
okay,
have.
but the student is not join. I don't know because I was thinking some sort of the concept and question both.
Yes, yes. That is good.
But I think some student feeling the bore when I discuss the
No, no,
concept.
no.
I
I
think.
don't think they feel bored, sir. They like it.
Yeah,
They,
yeah, definitely, but not for you. I think some student,
yeah,
because
I
of
got it.
the yeah,
Because no,
because
sir, they respond very well. They respond very well. So last time, very lively discussion.
you can share your also your email ID in the chat box. Then I can send you the some extra material and also
That's right. Yeah.
yeah. And you are looking very interested in the fluid mechanics as well. I think you are asking someday about the river engineering TSC, right?
Oh yes, sir. Yes.
Yeah, so this time is not available because okay, I will send just I want note down. I will send some study material, right?
Great, sir. Will be fantastic.
P Naik.
Yes, sir. pnike.in@gmail.com.
You are from which state?
I'm in Odisha, sir.
Oh, you are from Odisha.
Yeah. Yeah.
Oh, yeah. Professor Subhasis Datta also from Odisha.
Oh, is it,
Who
sir?
is yeah, who is teaching the your fluid mechanics course
Oh, I
and
see.
river engineering also
Yes, yes.
from
Yeah.
yeah.
Yes.
Okay, I will send you some study material. So I think today very No one joined, only you. And how can we start? I think we start.
Okay, so yeah.
Yeah.
Otherwise, the next week, if you want to postpone, sir, you can postpone it if you are interested. So,
No, no, we'll not postpone because I can't postpone the
yeah.
this TA session because this is handled by the IIT Madras,
Oh, I see.
not
Right.
by yeah.
Right. Yeah, got it.
All the your I think before starting the this session live session you got the some mail from somewhere of NPTL from NPTL side, right?
Yes, sir. Yes, sir. Yes.
Yeah, so this message was sended by the IIT Madras team, not
Oh, I
here.
see. Right,
Yeah,
right, sir.
so
Yes, sir.
I can't delay or
One it, yes.
something.
Got
Yeah.
it.
Okay, Pradeep, I just want to show you some first question and you try.
Yes, sir. Yeah.
Then we'll explain you concepts. Question is visible to you.
Uh,
Question is visible.
so it is a bit small actually. Can you enlarge it a bit?
Yes, yes, definitely sure. Now question is visible clearly. Hello.
So it is visible now, sir.
Okay, okay. First question is about the two-dimensional duct flow, right?
Yes, yes, yes.
Okay.
Close in the bottom half of the duck of velocity. Upper half. Yeah. So is it half mv square, sir, kinetic energy? The,
Yes, yes, yes.
right. So it should be
Yeah, which option? C option.
C option, yeah.
Yeah,
C.
it's okay. You try also the second one. Yes, please solve the question number second. I think someone joined. The Vinay is joined. Hello, Vinay. Hello.
He went out.
Some network problem also there somewhere.
So the screen is not visible in this.
Okay, okay, okay. Just I am sharing.
Yeah.
Just wait 1 minute. Just.
No problems.
You are in which semester?
No, sir. Actually, I'm working in a private company.
Okay, okay. You are a which company?
It is a private consultancy, sir. Private
Oh, oh, oh,
NGO.
you are preparing for gate.
Yes, sort of. Yes, yes, actually.
Okay, okay, okay. Then these type of question will help you more. Okay, if you are preparing for gate or some other exam also you are looking.
No, 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 sir. No, only.
Okay, this type of question also SSC JE. You know
Yeah.
about the SSC JE, na?
Yes, sir. Yeah, yeah,
Yeah, this type of questions also from SSC JE because nowadays the competition level is very different and
yeah.
very difficult
Yes.
because the lots of candidates and vacancy is very less. So these type of questions will help you lot.
Yes, sir. Yeah.
Question number two, right? Now it is visible. Yeah, Pradeep, it is visible right now.
Yes, sir. Yeah, yes, sir. Visible now. Little bit if you enlarge it slightly.
Yeah, yeah, definitely sure. The second question is the a water jet with a velocity of 20 meter per second is directed upward.
Yes, sir. Yeah.
Basically, this question is based on the projectile motion, whatever you have studied in
Yes,
the
sir.
12 also.
Yeah.
So it is very simple.
Yeah.
And your bachelor degree in the civil engineering.
Yes, sir. Yeah.
Okay,
Actually,
okay,
sir, I'm preparing AMI, sir. Actually, so I'm just
okay, okay,
just
okay.
so I'm appearing for final.
Yeah, yeah, it's good, good.
So it should be, sir. 10.
So for that question, question number two, you can go through some this concept.
So
Just I want to show you. Yeah, for the question number two, you can go through just this concept. Uh, a water jet, like you just consider this is the water jet
yes, sir.
at 45 degree
Yeah. Yeah.
from the horizontal,
So
just straight line draw it, just for reference. And like that, your water jet go and go down.
yeah.
Right.
Yes. Yeah.
Question is asking about the velocity. Velocity is how much? The 20 meter per second.
Yeah.
This type of question you can expect in the gate also.
So
And this is the, and if you try to break the component, this is the sign, this is 45 degree, right?
so yeah.
The 20 cos 45 degree,
Yes.
and this one is a 20 sine 45 degree.
45 degree.
Now the question is, if air resistance is neglected, okay, it will reach a maximum elevation at the horizontal axis. Here you know the maximum elevation. This is, you just assume h at a horizontal distance x. Okay, from here to, you just assume at,
So actually, it not since it will reach a maximum of maximum one something one
oh no, no, this one is not
or at
oh,
one
this one is not
or
in the
at one.
question. Yeah,
Or at,
yeah,
okay.
yeah, yeah, this one is not in the question. Okay, now this is the your x. Now the question is about the value of x in meter.
Yes.
Okay, so now the formula you know already, the u is equal to,
Yeah.
v is equal to, actually v is equal to u plus 8. Here the formula will apply the not 80. Here we will use the gt, because of the this projectile motion go in the upward and fall down in the down. Because where we use the a we use at the surface where the, in let's say the car is moving with the acceleration of, with some acceleration, but here we use the acceleration due to gravity, right?
Yes. Sir.
And the acceleration due to gravity will take here the minus, because of the velocity is going your upward direction, right?
Yes.
And acceleration due to gravity in the downward direction, right?
Yeah.
So we'll take minus, not positive. One formula also is there. S is equal to ut minus half gt square, you know also. And one formula also, v square is equal to u square plus 2as 2gs. This is also minus, not positive. When we use the a, then this is the now positive. So using this formula you can calculate.
So yeah. Yes. Yes.
Yeah, you just go through, then I will explain again. This is the t. Or one thing you also know, at the highest point the final velocity is 0.
Yeah.
Your initial velocity is this much, 20 sine 45. Hello, Pradeep, you are solving still?
I think it is at 20 something. Yeah.
Yeah, it is like that. Yeah, 20.38, I think.
Yeah.
Yeah, okay. Now we can move on the next question. Question number three is visible, Pradeep?
Uh, yeah, yeah, possible, sir, but little bit bigger, little better actually.
Okay, okay.
Other friends also have joined now, sir.
Yeah, I have seen.
Yeah, it looks better now.
Hello, everyone participates. Vinay, you also participates in the question answer session. Question number three is you solve, and question number four. Just write your answer in the chat box, whether option A, C, B, and D, which one is correct. The question number three is about in a turbine having a flow of 1.2 meter cube per second, the net head is 120 meter. If the efficiency of the turbine is 90%, the shaft power developed in kilowatt each. So here you need to find out the shaft power. Very basic question. The question number three is asking about the efficiency of turbine. It's given the efficiency of turbine actually 90. We denoted the efficiency generally by eta 90%. The shaft power developed, asking about the power, shaft power. S stand for shaft. How much? You all know the formula. Density here is the kg per meter cube. G in the meter per second square. Q is in meter cube per second, and H is the meter. If you will combine, this goes off, and kg meter per second square, this is a Newton. Discharge is given, now something here. Discharge is given 1.2 meter cube per second. Net head is given the 120. If the efficiency of turbine is this much, the shaft power developed in how much? So rho you can take the 1000 into 1.2 into 120 into 9.81. If the efficiency of the turbine is 90, so you can multiply with the 90, that is the 0.9. So please write your answer in the chat box for option number, for question number 3. Okay, now I want to explain. Okay, you all know the efficiency is equal to output by input, or output by input. So your input is a water power, that is the how much your power of jet. So water power is equal to rho q gh. So your input is this much. rho Q GH, right? And here is your output is the shaft power. So in question asking the shaft power is equal to efficiency into rho into Q into G into H. So how much efficiency? Efficiency 20%, you divide the 100 and get the 0.9, and rho is equal to 1000. Now I want to write here 0.9 into 1000, Q is equal to 1.2, and 9.81, H is given 120. So how much? 1.2 into 9.81 into 120. That is the 1271376. So your answer, the shaft power in kilowatt. So you can divide this by 1000. So approximately is equal to 1271. So near about answer is the option number D.
Yes,
One
sir. Yes.
two, yeah. Option number D is the correct. You always remember the efficiency is equal to output by input. How much you have put the input and how much you getting. And this formula output by input is used in very practical way also, lots of places. So you always remember these things. And how we get the, how I know this rho QG is the water power, you please go through the lecture, and I think some basic lecture we will go, then you can get the how this one. The water power is equal to Y rho QGH. Now the question number 4, the continuity equation deals with the law of conservation of what? Mass, momentum, energy, and none of the above. Please write your answer in the chat box. Okay, Pradeep, your question is about the a water jet strike a stationary horizontal plate. Okay.
Yes, sir. That dam. Yeah.
Okay,
That's
I will discuss this question.
correct, sir. Yeah.
No, I will not tell you the exact answer because of this is your assignment part, but I will tell you the concept. How can you go through this question and how? Okay, and definitely you will get the answer.
So the date is already gone for that, for the question, for that horizontal plate.
Yeah.
The date is already gone, sir, but by vertical.
Okay, okay. Then I will tell you. Then I will tell you the exact answer. Okay, 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 okay. No problem.
For the second question, sir, it is the current one now
Which
at the
one?
moment. The water jet, sir. The
That is last one question you asking. Water bucket.
no, sir. The water jet strikes stationary horizontal plate vertically at the end.
This is the current.
Yeah, the current one, sir. Yeah.
Okay, then this
Matching with the, it is
yeah,
not matching with the
okay,
same.
for this question I will give you the hint.
Right.
How can you go through approach the question?
Sure.
And all other question I will solve. No problem.
That's yeah. Thank you, sir.
I think this question you also asked in the previous class, right? A vertical
Yeah,
rectangular.
vertical
You
like
have, yeah, you have given the your, yeah, my email ID. Then I will send you definitely.
that is
And
yeah.
if
Thank you.
someone want to also the some have the problem, or you can, okay, I want to write here my the WhatsApp number. You can also send me the question on WhatsApp for your personal fluid mechanics question, not from the assignment and other. If you have doubt, you can ask. Or I have written here my or this WhatsApp number, right? In the chat box. So it is good. So please feel free to ask a question on WhatsApp. No problem. Yeah, I have written my name and number on the chat box. You can go through it. The Vinay is actually
Uh,
Babo is telling the option number B is correct. The continuity equation deals with the law of conservation. Okay, we'll see the Pradeep. Your answer is conservation of mass, and other two. Please also give your answer. Other two student. Sing. What about question number 4? Your answer. Please give your answer. And the Sarif also. Okay, Sarif is telling the option number B. Okay. No, actually the continuity equation is based on the conservation of mass. Now I want to explain something. You know the continuity equation for flow. Let's assume the flow in the pipe. Water is entering from here and leaving from here. And assumption is the steady flow, steady and uniform flow. And second assumption is incompressible flow. Incompressible flow means your density will be constant, right? Your density will be constant. Or a steady flow means the change in flow characteristics, let's say velocity, with time does not change. This is the definition of a steady flow. At the place of velocity, you can put some other flow characteristics also. So here, the momentum, that is the your continuity equation, is based on the mass of conservation. That is how much mass is entering here and how much mass leaving here output. So you know formula, very popular formula, A1 V1 is equal to, this is the cross section A and cross section 2, A1 A2 V2. That is whatever is entering from the at section 1, the leaving, whatever the leaving, this should be equal. This is the meaning of the conservation of mass. And your continuity equation is derived based on this assumption. The momentum equation, if you talking about the momentum equation, you know about the your this one Bernoulli equation and also the Navier-Stokes equation. These are based on the conservation of, your Navier-Stokes equation is based on the conservation of momentum. Okay, the I think question is not visible. Now I think visible.
yes.
The question number 6 and 7.
Yep.
Question number 6 is about question is telling the necessary condition for the flow to be unsteady. I have tell just you choose the answer based on the concept. And which is question number 7 is about which one of the following is the intensive property. So question number 6, please go through the question number 6, the necessary condition for unsteady flow. The option number A is the velocity does not change from place to place. Okay. Option B is the velocity change at a point with respect to time. Option C, the velocity is constant at a point with respect to time. And option D, none of the above. Please write your answer in the chat box. Okay, for 6, Sarif is telling the option number B is correct. Okay. Velocity changes at a point with respect to time. Okay, Sarif is telling. And Babo is also telling the option number B. Okay, everyone telling the option number B is correct. Yeah, option number B is correct for the question number 6. For unsteady flow condition, the flow characteristics like velocity does not will change with the time with respect to time. In case of a steady flow, it will not change with respect to time. And for option number A, the velocity does not change from place to place. This is the definition of the uh, uniform flow. Which of the following is the intensive property? You know about the intensive property and the extensive property. If you have some, I have some trick I will tell you, because sometimes I also forget about it, but I have trick. I will tell you, you will be always remember. Okay, someone is telling option number B, someone telling the option number C. Okay, let's see. Let's see which one is correct. The extensive property and the intensive property means, okay. The extensive property means and intensive. Here is the question about the intensive property, not extensive. Extensive property means a property which depend on mass. Intensive property means property which does not depend on mass. Does not depend on mass. So yeah, mass is depend on the mass. Volume also depend. Volume also depend on the mass. If for example, you know the how if your volume will be increased, then your mass will be increased definitely. And yeah, someone telling the option number B. Yes, B is correct. Rho is equal to m by v. So m by v ratio is always constant for any material. Though that is your density is not depend on mass. Whether you, if let's say you have some, let's say, soil, some packet of soil, or you can also take the example of water. So whether if you take this much water from here, the density of this much water is same of this total water, because the definition of the density is mass by volume. So in how much volume, how much will be the mass. So this is the intensive property, and trick is about just this is a not the conceptual trick. Just for your remember, the extensive means it name is itself. This is for just trick, not any scientific reason. Uh, so extensive is something you can extend. Extensive is the sense give the something should be extended. If you have mass in something, then you can extend only, otherwise not. So that is the extensive property, depend on mass, because if something have mass, then you can extend only. So this is the trick. This is not scientific. This is not related in the scientific. Sometimes people might forget about the what is the actually some confusion between the
Sir,
extensive and intensive.
extend means, sir, extend means.
Extend is you can just drag something, right?
Okay, yeah,
Yeah, if you have the more, oh, this is not this definition is not related any your, yeah.
I got it, sir.
Yeah, this is your any scientific, and just for remember, I, yeah, sometimes I forget about the extensive and intensive. What is the difference suddenly? Then you just remember the extensive means just you can extend something. So if you want to extend something, then it should have the mass. So then you can extend. So you can relate this, but this is not correct definition. Okay, correct definition is the extensive property, that property which depend on mass, and intensive property that does not depend on the mass. So now we'll move on the next question. Then we'll have some break. Yeah, question number 8 is visible to all of you. Please. Question number 8. Identify the statement below and choose the correct answer. Statement A control volume focus on a set of fluid particle. Statement B, a control volume can be fixed, movable or deformable. This thing I think sir is explained very well about the control volume. So please I expect from you this should be correct. Okay, you people give the almost correct answer to all of the questions. So I also expect this question should be correct from your side. Question is visible to all of you, no? Question number 8 and 9.
Yes, sir, visible.
Okay, okay. Give your answer. Write your answer in the chat box. Someone is asking about the what is control volume. Okay, I will explain. Yeah, for question number 8, option C and D. Option C is correct. Okay, A is false and B is true. Okay, yes. For control volume, focus on set of particles. This is wrong. A control volume have a fixed, movable, and deformable volume. It's correct. Okay, I will. Now I want to explain this one. And question number 9, please also give answer. Webo, I'm just I will explain. Okay, let's see the control volume. You have let's say the river like that. Water is flowing from this direction to this direction, and you want to study how the velocity changes with time. Let's say velocity only, and you stand here. Let's say the stand here someone, and want to see how the velocity changes. So here two people is stand, just for your convenient I want to tell in something different way. So first people want to study the flow characteristics with some packet of fluid. Let's say this is the packet of fluid. Packet of fluid means the combination of lots of fluid molecules, the packet of fluid, and he observing the how this fluid is, how fluid particle is behaving. Just reaching here, this is the same fluid particle, not different. This concept is known as the control system, not control volume. In case of control volume, what you will do, at a cross section, or not entire cross section, you can take also some volume, and you just see what is happening in the control. This is the control system. What is happening, this is the control space or control volume. Particle is entering and particle is going out. uh, the particle identity changes with time. Here identity is not changed. The particle, whatever here, then same particle here. But in this case, control volume system, new particle entering, leaving, some new particle entering, leaving. So only you focusing on this, the whether in this control volume velocity it changes with respect to time, how much changes, and how much pressure changes. So this type of a study known as the uh, control volume, and this type of a study is known as the whatever the first person is studying, this is known as the control system. And how will we study? If you want to study the using the control system, then you can leave, just for a generalization point of view I want to tell, you leave your instrument in the river. When you leave your instrument, then instrument will also flow with the fluid particle. This type of study, your instrument is moving with the fluid, floating in the fluid and moving in the forward direction, and fluid particle also moving in the forward direction. And whatever the velocity of your fluid particle, the same velocity of the your instrument, because it is floating. And this type of study, using this concept, you can generalize the you can just remember the control system. And if you focusing only on the fixed point and a fixed location, this study is known as a, you just fix your, let's say that just you fix your instrument at the fixed point, at a fixed point you have fixed your instrument at a fixed point. So this type of a study known as a control volume system, because your instrument is fixing at a single point, not moving with the water. If your instrument is moving with the water, then it is a control system, not control volume system. I think it should
And
be
that
clear.
is a fixed, removable also. It is saying
Yeah,
it's
yeah,
removable.
I'm telling about only the fix.
Right,
Yeah,
sir.
in some cases, for this, for your simplicity, just I'm telling, I have considered the fixed control volume. This is the
Sure.
fixed control volume. Okay. So who is asking? Webo, you got it? Yes, please. Webo, you got it, the concept about the control volume and control system? Yes, okay. Okay. Or please solve the question number 9. Does the velocity field, yeah, this is a very simple question. Then after we'll take some break of 5 minutes. After question number 9, we'll take a break of 5 minutes. The question number 9 is about the, does the velocity field, that is the v is equal to this, you all know the velocity is uy plus vj cap. I want to put cap, and also someone, you can put the air arrow, and wk. So does the velocity field, this much, represent the possible incompressible flow of fluid? Yes or no? Incompressible. This is the condition. Okay, you multiply this and you will get the formula is that del by del x. If it is equal to 0, then your flow is incompressible, otherwise not. Whether the option number A, B, and which one is correct, please write your answer in the chat box.
So it is difficult to break the equation how the V bar is equal to this. So the right sides are there RHS. The I don't know how to put that in this equation.
Okay, okay, okay. I will explain. Let's here vector V. Just I have written the value is this, and the this is related this. So U is equal to how much? 5x cube, right?
Yeah. Yes, sir.
And V is equal to how much? Minus 15x cube, x
Yeah.
square actually, x square y, and W is equal to how much? T, right?
T, sir. Yeah.
So formula is that
Yeah.
delta by x, delta V by y plus delta W by z.
All right. I got it, sir. Yeah.
So if you put it the U, then what will happen here? I want to just new slide. So what will happen? U is equal to U is how much? The 5x cube plus del y minus 15x square y plus del y del z t. So this is 15x square minus 15 square. This is the constant,
Yeah.
and when you will just I want to write here del y is equal to 1, and here is how, what del by del z into
Zero.
t.
Yeah.
Let's say the t is constant, but here 1, so this is 0. So 15x square minus 15x square is equal to 0.
Yeah.
So this condition is valid for
Yes.
this equation.
Yes. Yes.
So this flow is incompressible, right?
Yes.
So option number A is correct. Okay, we'll have some problem number 10. Correct answer is not given. A water jet strike. Okay. Assignment 3, week 3. A water jet strike a stationary horizontal plate vertically at a rate of this with a velocity 20 meter per second. The mass of the plate is 12 kg. Okay, just I want to try to solve. You people also try to solve. Just I want to see because lots of problem in this question. A water jet strike a horizontal plate vertically. Okay, some horizontal plate is given and vertically strike with a mass flow rate lambda is equal to 18 kg per second. Okay, with a velocity this 20 meter per second. The mass of the plate is 12 kg. 12 kg. Okay. Assume the water stream move with the horizontal direction after a strike. Okay. Water strike move in the horizontal direction. prevent the plate from move vertically. This force is asking. So you can F is equal to how much? 12 into G equal to force 18 into 20. Okay, now I got the answer. I will explain. I want to explain this concept. Then people you go through that.
I also got 360. So I think the questions, the answers, I think 260 should be 360 probably. The answer,
Okay, no. I want to explain.
actually.
Just I have solved not 360 answer here. The question is given. A plate is there, right?
Yes.
A plate is there and some water jet strike, right, vertically,
Yes, sir.
and also given the this horizontally moving after striking your water horizontally moving, right, in this direction.
Yeah.
This is the given already in the question,
Yes.
and velocity is given of the water jet is 20, right, and the mass flow rate is given. How much mass flow rate? That is the mass flow rate notation, m dot 18 kg per second, right?
Yes.
Okay, 18 kg per second. The question and the weight of the plate is how much? 12 kg.
Well, yes.
And how much force is required to fix the plate, right?
Yeah. So that
Not move in the upward direction, right?
it will not move upward direction.
Yeah. So you just need to summation of the all forces in the upward direction, right? Let's say the vertical direction, right? For the equilibrium condition, for a stable condition, what is a stable condition definition? The force in the direction should be equal, right? Like here case is the in the vertical direction and the downward direction should be force equal. When the, let's say the downward force and the upward force when equal, then what will happen? The plate, your plate will not move the vertically, right?
Yes.
And that is the asking in the question. So what you do, you will do the force is equal to, then and here how much force? Vertical force. And if you go through this one, this is the upward equal to downward, right?
Yes.
So you can apply the downward equal to force upward. So how much downward force is here? Let's say this is the vertical v, fv plus 12. The weight of the plate is how much? 12 into g, right? So 12 into g equal to, this is the vertical force and this is equal to m dot into v. Now you can solve the question, right? Apply this. You are getting. Now you can calculate from here the vertical velocity. I think now I think you all have the clarity about. You are getting now this one.
Yes.
So when you will solve, this is a 360 minus something, right? So question in the, I think it should be correct, not 360. So what is the answer? Okay. Sarif is telling okay, thank you. Okay, welcome. No problem. If you have doubt, you can ask. Because I am also learning with you. Whenever you ask the question, then definitely, indirectly, it will help also me. So now, Pradeep, I think you have cleared. The Sarif is telling it's
Two,
clear, or
yeah, two,
okay,
two, yeah.
okay. So we'll take some break of the 5 minutes. Then after we'll move on the another question, right?
Yes, sir.
Okay, we have some break of the 5 minutes. Yeah, now I will start the question number 10. Hello, everyone present? Yeah, okay, Singh. You solved the question number 10. The Reynolds transport theorem is option A is applicable to a study and unstudy solutions, not solution, the situations. Option B is for about the applies only to conserve properties. Option C both A and B, and option D is only B. Question number 10. Reynolds transport theorem done. You have already, I think, studied in the week 3 Reynolds transport theorem. If yes, please write in the chat box yes. And according to that, I will explain the answer. Reynolds transport theorem. The Reynolds transport theorem is yes applicable to a study and unstudy both, and also apply on the conservation properties. So option number C is correct for the question number 10. Now 11, question number 11 is visible to all of you. Yes, please, anyone tell. The question number 11 is visible. Question number 11 is visible. Yes, anyone please tell. Or also in the write in the chat box. Yes or no. Question number 11 is very conceptual question. So I will explain. Yes, anyone solving the question number 11? Otherwise, I will explain the question number 11. And also, Pradeep is asked
Question
whatever
number
you have
10.
asked. Yes.
Question number 10 side is C, or the question number 10, so the answer
Yeah,
uh,
for question number 10, option number C is correct.
is correct. Correct. Sure. So number 11 needs some explanation, sir.
Yeah, we just take our time, then I will explain. It's a very simple. It's look like very tough question, uh, but the concept behind is very simple. The question number 11, the concept is very simple. Yes, question number 11 is asking about a syringe. A syringe as shown in the figure is used to inoculate a cow. Okay, this is only a statement. The plunger has a face area 500 meter square. This is the plunger, and the face area is how much? The 500. This is the in figure, like I want to draw here. Some sort this look like the this area is given 500 square. The liquid in this in the syringe is to be injected steadily at the rate is given also 300 centimeter cube per minute. Okay. Now what is asking? a leak rate is given. This is the, or in the backflow, leak here means the backflow is how much? 0.1 times of volume flow rate in the needle, that is the Q. This is the backflow is given. Find with what speed should be plunger be advanced. The question is asking about the speed, what should be the speed of plunger, so that this much amount should not be back, this much amount should not be waste as a leak waste. So what we do, we design something, the design velocity, design discharge should be the your this, that is the 3 centimeter cube per second plus the leak one 0.1 times 300. This is the your design. When you will design like that, your plunger velocity, when you will design like that, your 300 and plus leak, uh, the speed of the plunger should be designed like that, it will be capable to the, also it will capable to also the this injected capable to inject the all amount, not come back. So what you will do, 300 plus what should amount come back, that is the leakage problem, so you should also incorporate in your design. So how much? 300 plus 30, 330. The velocity is equal to how much? Area, centimeter square per minute. And what is the, that is your speed of plunger. The plunger area is how much? 500 mm, 500 mm square. So you need to convert in the centimeter, so it is 2 power 2 minus 2 actually. So 300 divided by 500 into 10 to the power minus 2. So how much answer? Gone. That is the, when you will calculate, your answer will be, this is a minus 2. Your answer will be 300 divided by 500 into 10 to the power minus 2. Answer is comes out to be 60. 60 what? Centimeter per minute. But the asking the mm per minute, so you will multiply by 10, so that is the 600 mm per minute. Your velocity should be 600 mm per minute for a plunger. So I everyone got the concept.
Sir, this V is equal to, why did you do this 300 by 500?
Yeah. Oh, yes, Pradeep. What did you asking?
You did, sir, V is equal to the 300 by 500. Um,
Yes.
the, how did
Okay.
you?
Okay. 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 Just I want to. Just I will tell. Your discharge is equal to, formula is velocity into area.
Yeah,
So here you want to find out the velocity of plunger. So discharge divided by area of plunger, right? This is not area of plunger. So discharge is how much? 300 plus you want to design for extra amount what is wasting, whatever wasting.
yeah,
So yes, so
okay,
0.1 times of the 300.
yeah,
This is given in the question.
yes,
And area is how much? 500. This is given in mm, but This is centimeter cube per minute. So you need to also put it 500 in the centimeter. So for conversion, you need to multiply by minus 2 because in 1 mm is equal to,
Yeah, got it, sir.
yeah, 1 centimeter is equal to 10 mm. So 1 mm is equal to how much? 1 by 10 centimeter. So 10 to the power minus 1. Okay.
Yeah,
So 1 mm square means how much? 10 to the power minus 1 square this side also, so 10 to the power minus 2. That's why I have multiplied here minus 2. Okay. This is the concept behind it. So this question is also very easy. Pradeep, you have asked the question, a garden house attached with a nozzle, right?
yes, yes, sir, yeah.
So you try once. You just, I think I have you have doubt about the liter per second and kg, right? So
Yes,
liter
last
and kg is same thing. In case
same
of
thing.
water, you can consider.
Yeah,
You solve that question. And one question was about also a vertical rectangular gate 2 meter wide. Or in between, you just solve the new question. So question number, yeah, this is the again very easy question. Yes, please. Whatever we have explained, this similar question is. So I think you all know about this question. Identify the statement below, choose the correct answer. So statement A is a system focus on a set of fluid particle. You all know the, and option number B, a control volume focus on a region of a space.
we did this already, sir.
Yeah, the both option is correct. The system, sometimes the control mass system is also known as only system. So this is the definition. This is the meaning here. System meaning here the control mass system. So option B and A also both correct. So you can go through the option number A. A and B are true. And which of the following is the intensive property? Just I have explained you the what do you mean by extensive property and intensive property. So intensive property, what is the your density?
Energy.
Yeah, not energy.
No, no, no.
Pradeep, yeah, or density, because energy also depend on your mass. Now here is another concept. Which of the following is a extensive property? Now just you uh, focus on the question number 3. Very easy question. Whatever I have explained earlier. Go through that concept, and also you can use a little bit your trick where if you forgot about the concept. Now I am looking the your question, a vertical gate of 2 meter wide. Okay. Yeah, it is also very easy question, Pradeep. Just I will,
Yes, yes, sir.
yeah, just I will explain the diagram and free body diagram. Then you can easily solve this question. This type of question you can also expect in your exam.
Yeah.
So you can easily tell here the answer of extensive property is what? Which depend on the mass. Or what is the correct answer? You know about the momentum, na? Velocity.
Yeah. Momentum. Yes.
Yeah, momentum is equal to velocity or mass into velocity, right?
Yes.
So this is the momentum is the correct option. And you know the continuity equation deals with the law of conservation of mass. Now your question is about a vertical gate is there. Not, yeah, gate is there of width. So how much? Width is 2.2
5 meter.
meter, 2
2 meter.
meter, and height is how much? 2.5 meter, right?
Yes.
And hinge at the bottom. And if you see from the side view, then it will look like that, right? Just you think the your width is inside the like that. You are getting,
Yes, sir. Yeah.
yeah, what I am drawing, I think you are getting. Okay, and this is also, so this is the water, right?
Yes.
Inside the water is there. This is a 2 meter and 2.5 meter. So at that point is hinge, right?
Yeah.
At that point is hinge. So now I want to draw like that. At that point hinge, and this gate is horizontally connect with the chain, right? Horizontally connect with the chain, right?
Yes.
So this the pressure of water will act on that like that, you know already.
Yes.
So you calculate here the pressure rho gh, right? And it
Yes.
will be act at which location? Your the body is what type? Rectangular type. So you know the what is the center of gravity, right?
Yes.
And also you can calculate the center of pressure, right?
Yeah.
So where is your center of pressure? Like you just your center of gravity at the mid, and center of pressure will be little bit down. So you calculate this height, right? If you
Yes.
calculate this height, then you can get the this length, right? Because 2.5 minus, let's say this is HC, right?
Yeah.
So and the question is asking about the tension is how much. So you can calculate the tension from here. This is the tension. You can take the momentum about that. Let's say that your pressure force is this. So pressure force, how much pressure force? Your force, let's say the pressure force is equal to PF or FP. FP, you take the momentum at that. FP, what is the definition of momentum? Force into perpendicular distance at the point, at the hinge. So FP into how much distance? This one, 2.5 minus HC. This is the this direction, and this one will be the how this direction. Actually, your T in this direction and the pressure force in this direction. So it will be equal. So tension into distance is how much? 2.5. So only here, uh, The tension and your force you will calculate easily, how much the force at that point, if and height you can also calculate. So with that concept you can go through this question, right?
Yeah. Yes.
Okay, now we'll, I think another session will on the Monday, fluid kinematics, right?
Yes.
Okay, I will explain the some previous year assignment question and concept about the fluid kinematics. So okay, thank you all. I will meet again on the next Monday. Okay,
Thank you,
bye
sir.
bye.
Thank you, sir. Bye.
Okay, bye bye. Take care. Yeah, Sarif is taking about the volume intensive property. Why volume? Actually, I'm not getting the question. What you asking? Why not the volume is intensive property? This is it like that? Where is the volume? Yeah. Yeah, your volume is depend on mass. Let's say I want to give your question, my answer. Let's say this much, let's say the potato 336. Here is the 3 potato, 6 potato, mass is m1 and volume is v1. If you take the potato, number of potato is 25, you take the potato of 20, then what will happen? The mass will different, volume will different. So your volume, as mass is changes, volume changes. As mass is changes, volume changes. So volume is the extensive property, not intensive. I think, okay, okay, thank you. Density depends on mass. Okay, I want to correct. Okay, I will tell you, just wait few minutes. Density, let's say the water, just consider the water. This is the water. Density is the ratio of mass by volume. Okay, so if you will take the this much water, let's say outside, so the ratio of this, let's say mass is m1 and the volume is v1, and if you take that much, mass is m2 and volume is v2, the ratio of, if you calculate the density of this much mass, so m1 and v1, and this is m rho 2 is equal to m2 by v2, this will be equal always. This the ratio will be equal. Mass is the difference, only the magnitude, but ratio will be always equal. Okay, 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 Sarif, thank you. If you have any doubt, welcome, no problem. If you have any doubt, you can ask, and I have also here given my this WhatsApp number. You can also give your question on WhatsApp also. Okay, thank you all.